Hello, in this lecture we'll be doing chemistry. First of all, I will give you an introduction on what is an atom and the way in which electrons orbit around an atom. Okay, now I hope you know what you have. I hope you have studied in your high school that electrons are assigned in specific shells, the K, L, M, N shells. Now that is classical chemistry. In the real world, atoms are arranged in orbitals. Now what? I will write it down. It's not orbit. Orbitals. That's where the electrons are found in an atom. Now, this is an example of a, I'll write it in another color, of a hydrogen. This is a hydrogen atom. Okay, this is the structure of a hydrogen atom. Now this white part over here is the nucleus. And these black parts are the probability where an electron can be found. It's just a probability, it's not a definite path. When it comes to orbitals, we don't have a definite path or a definite path. We just have a probability of finding an electron over there. Okay, so in hydrogen, the atom can be here, 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 or here, or here, or here, or here, or maybe even here, here. But it's just that as it closes to the center, the density increases, and that's why you can see it's more black over here and less black. So here, the probability of finding an electron over here is very less. That's why it's white. Whereas the probability is maximum over here. That's why it's very black. So that is how we divide. That is the basic idea of an orbital. Okay, now you know atomic number. It is represented by Z. You also know atomic mass, A, and it has a unit AMU, atomic mass unit. Now, what is the mass? What is the mass of an electron? Sorry, mass of an atom. Mass of an atom. The mass of an atom is the number of neutrons plus the number of protons. It's not electrons. It is the number of neutrons plus the number of protons. Now that is why if it was the number of electrons, you would get a double of the atomic number of the atom, since the protons and electrons are same for all stable elements or compounds. Okay, now that is the mass of an atom. For example, we'll take an example. I'll do it in another color, pink. Carbon. Take carbon 12. Sorry, carbon 12. Now, what is the atomic number? Atomic number of carbon is 6, right? So, if you look in the periodic table, you will find that the mass of carbon is given as 12.011 something. I think it's 7. Okay, how can that be a fraction? You can't have a neutron, half of a neutron cannot exist like that, right? And how the hell did it become 12.10011? It's impossible, right? No, there's a definition to it, because in a periodic table the atomic mass is given as the average of the atomic masses of different isotopes. Now that's a problem what isotopes pose. Isotopes. The average of the isotopes is the atomic mass given in a periodic table. Now that's why, oops, sorry, wrong tool. That's why you have a fraction or a decimal in the periodic table where the atomic mass is given. Okay, now the mass of an electron. Okay, I need to clear this. How the hell will I clear this? Okay, I'll paint it black. Yes, this one also. You know, I changed my color to black, you know, because when it was white it took a lot of time to get it uploaded on YouTube. I think black takes less time, and that's why Khan Academy does like that. He does in black. Salman Khan does in black. Okay, now the size of an the size of an electron, or let's consider an let this be the nucleus of an atom, and when we draw in figures we will draw that the orbital or the orbit over here, right? That's not scientifically correct, because the nucleus, there is a ratio between the nucleus, the size of the nucleus or the volume of the nucleus is actually 1 by 10,000 of the volume of the total volume of the atom, atomic volume. See, so it's actually, when we draw it like this, it's actually scientifically not correct. So one thing you should know when you know about atoms, or when you are changed from classical chemistry, is that it is always a probability function. Probability function. Oops. Probability function. Now that is what these orbitals are. It's just a probability function. Now, for example, okay, I'll talk about that when I say about the different types of orbitals and the SPDF orbitals. Okay, now you might ask, there is a common doubt which comes, is that I just said that the radius of the atom will be 1 by 10,000 of the radius of the nucleus. So what? So the size of the electron will be a small part of it, right? Like this much. So what the hell is between them? Between the nucleus and the electron? You said you have hydrogen and 1000 gap. I mean 1 by 1000 of the total radius is just the nucleus. So what the hell is between the electron and the nucleus? It's just vacuum. I know it's hard. It's just vacuum. It's just vacuum. So it's surprising to know that most of the things we touch have more vacuum than stuff. Similarly, I don't know more about that. I'm just a 10th grade guy. So when we touch things, we can't pass through it. Similarly, because we have atoms, we also have atoms as the things we touch. I think so. I don't have a possible explanation for that. I don't think it's even found. Okay, so we talked about isotopes, the problems that isotopes posed. Okay, I'll just tell one more thing about the structure or the position of electron. Okay, we said and one more property is that I'll draw another orbit over oops, sorry. I'll draw one more orbit over here. I'll draw another one over here. Okay. Now suppose I have electrons all over these orbits. Suppose I have one. Oops, wrong two. Yeah. Suppose I have one over here, and some over here. I'm not taking the octet rule or anything based on I'm just simply putting some electrons. Now which of these electrons will have a higher charge? Which of them will have a higher charge? You know, you might possibly tell me that that the electron towards the nucleus has a higher charge, but that's not true. You might say because it's closer to the it has more charge, but that's not true. It's always the electron towards the outside that has more energy. More energy, and this one has less energy. I'll put it as E. And that is the same reason why ions are formed. Ions are formed by the donating or receiving of electron. Basically, when we consider this donating, so what happens is there's a tendency of losing this electron, and that is because it has high energy. And when its kinetic energy, the more the kinetic energy increases, it just breaks off from the atomic, the effective nuclear charge, and joins another atom. Okay, now that is about the energies. That is why we classify them like that. And in the next lecture, we'll be discussing about the different orbitals, that is the SPDF, and I'll give you a more idea of what this is. Okay, that's all.